Volume and capacity, part 3. Hello friends, welcome to our student support program for grade 9. Today you will learn about capacity, distinguish among different units of capacity, milliliters, centiliters, liters, convert units of capacity, milliliters, centiliters, liters, calculate capacity of given containers, and finally, solve problems involving capacity and volume. First, let's recall our definition of volume. Volume is the amount of space that an object occupies. Now, let's have a look at the definition of capacity. Capacity is the amount of liquid an object can hold. Units of volume are meter cube, centimeter cube, millimeter cube. Units of capacity are liters, centiliters, milliliters. Let's recall different conversions of capacity. 1 liter is equal to 100 centiliters. 1 liter is equal to 1000 milliliters. 1 centiliter is equal to 10 milliliters. Here are some real-life examples of capacity. Now, let's have a look at the calculation of capacity. Let's take a cube with dimension 1 centimeter. Volume of the cube will be 1 centimeter multiplied by 1 centimeter multiplied by 1 centimeter will give us 1 centimeter cube. If we take 1 milliliter of liquid and pour it in the cube, the 1 milliliter of liquid will occupy the space 1 centimeter cube completely. So, we can conclude that 1 milliliter is equivalent to 1 centimeter cube. Now, let's have a look at some equivalents of volume and capacity. As shown in the previous slide, we have 1 milliliter is equal to 1 centimeter cube. Therefore, 1000 milliliter is equal to 1000 centimeter cube. We know that 1 liter is equal to 1000 milliliters. So we can say that 1 liter is equal to 1000 centimeter cube. Here is a table that shows equivalence of volume and capacity in different units. You can refer to this table while doing your exercises. Exercise 1. Convert the following volumes to the units of capacity shown in the brackets. Now, let's solve some problems involving capacity and volume. Example 1. Find the volume and capacity of the cuboid. Volume of cuboid is equal to length multiplied by width multiplied by height. Substituting the values, we get 50 centimeters multiplied by 30 centimeters multiplied by 20 centimeters. Simplifying this, we get 30,000 centimeter cube. We know that 1 centimeter cube is equal to 1 milliliter, so the capacity is 30,000 milliliters. Dividing this by 10, we get 3,000 centiliters. Dividing this by 100, we get 30 liters. We can also divide 30,000 milliliters by 1,000 to get 30 liters directly. Example 2. Find the volume and capacity of the right prism. Volume of prism is equal to area of cross-section multiplied by length. Here the cross-section is a trapezium, so area of trapezium multiplied by length, which is equal to half multiplied by sum of parallel sides multiplied by height multiplied by length. Substituting the values, we get half multiplied by 9 plus 12 multiplied by 40 multiplied by 20 will give us volume in centimeter cube. Remember that here we need to use our BODMAS convention to simplify this. That is, bracket first and then multiplication. Simplifying it, we get 8,400 centimeter cube. The volume is equal to 8,400 centimeter cube. The capacity in milliliters will be, capacity is equal to 8,400 milliliters. Dividing this by 10, we get 840 centiliters. Dividing this by 100, or dividing 8,400 milliliters by 1,000, we get 8.4 liters. Example 3. Find the volume and capacity of the cylinder. Take pi to be 3.14. Volume of cylinder is equal to area of circle multiplied by height, which is equal to pi r square multiplied by h. Substituting the values, we get 3.14 multiplied by 16 to the square multiplied by 50 will give us volume in centimeter cube. Simplifying this, we get 40,192 centimeter cube. Volume is equal to 40,192 centimeter cube. Therefore, capacity is equal to 40,192 milliliters. Dividing this by 10, we get 4,019.2 centiliters. Dividing this by 100, or dividing 40,192 milliliters by 1,000, we get 40.192 liters. A quick recap before doing the exercises. 1 milliliter is equal to 1 centimeter cube. 1 liter is equal to 1,000 centimeter cube. Volume of a prism is equal to area of cross-section multiplied by length. Volume of cylinder is equal to area of circle multiplied by height. Exercise 2. For the following containers, calculate part 1, the volume in centimeter cube. Part 2, the capacity, giving your answers in liters. Exercise 2 continued. Now let's do some more problems involving capacity and volume. Example 1. An inflated swimming pool with base radius 1 meter and height 1 meter is half full of water. Take pi to be 3.14. Calculate the number of liters of water it contains. You have noticed that the pool is in the shape of a cylinder. So, to calculate the volume, we use the formula pi r square multiplied by h. Here we have to convert 1 meter radius into 100 centimeter. Substituting the values, we get 3.14 multiplied by 100 to the square. Note that the pool is half full. Therefore, the height of water will be half multiplied by 100 centimeters, which is equal to 50 centimeters. Now we substitute h by 50. Simplifying this, we are going to get volume in centimeter cube. Simplifying, we get 1,570,000 centimeter cube. Therefore, the capacity is equal to 1,570,000 milliliters. Converting this into liters, we divide it by 1,000 to get 1,570 liters. Example 2. A water tank in the form of a cuboid has dimensions 60 centimeters, 40 centimeters, and 90 centimeters. Part A. Given that the tank is 2/3 full, show that it contains 144 liters of water. Part B. 8 small metal balls are immersed in the tank, and the new height of water is 70 centimeters. Calculate the volume of 1 small metal ball. Part A. Volume of water is equal to length multiplied by width multiplied by height. Substituting the values, we get 60 multiplied by 40. Note that the tank is 2/3 full. Therefore, the height of water is equal to 2/3 multiplied by 90 centimeters, which gives us 60 centimeters. Now, we substitute the value of h by 60. Simplifying this, we are going to get volume in centimeter cube. Simplifying, we get 144,000 centimeter cube. Capacity is equal to 144,000 milliliters. Dividing this by 1,000, we get 144 liters. This is what we needed to show. Part B. Previously, the height of water was 60 centimeters. After immersing 8 small metal balls, the new height of water is 70 centimeters. Therefore, the rise in height is 70 minus 60 centimeters is equal to 10 centimeters. This rise in height of water represents an increase in volume of water. Increase in volume of water is equal to 60 multiplied by 40 multiplied by 10 will give us a volume in centimeter cube. Simplifying this, we get 24,000 centimeter cube. In increase in volume of water is equal to 24,000 centimeter cube. This increase in volume represents the volume of the 8 small metal balls. That is, volume of 8 small metal balls is equal to 24,000 centimeter cube. To calculate the volume of one small metal ball, we divide 24,000 by 8. Simplifying this, we get 3,000 centimeter cube. Here are some exercises for you to practice. Number 1. A rectangular tank of length 40 centimeters, width 30 centimeters, and height 50 centimeters can contain X liters of water. Calculate the value of X. Number 2. A cylindrical pool with base radius 2.1 meters holds 20,790 liters of water. Calculate the height of water in the pool. Take pi to be 22/7. Number 3. A cylindrical bottle with base radius 5 centimeters contains juice to a height of 20 centimeters. Part A. Taking pi to be 3.14, calculate the capacity of juice in bottle in liters. Part B. How many full cups of juice can you get if each cup has a capacity of 30 milliliters? What is the amount of juice left? Number 4. A rectangular tank of length 0.4 meters, width 0.7 meters, and height 0.6 meters contains 140 liters of water. Part A. Calculate the height of water in the tank. Give your answer in meters. Part B. 30 liters of are poured into the other tank. Explain what will happen, showing your workings clearly. Now that you have done some exercises, you can also visit these links to help you with this lesson. So friends, today you have learned about capacity, different units of capacity, milliliters, centiliters, liters, how to convert units of capacity, milliliters, centiliters, liters, how to calculate capacity of given containers, and how to solve problems involving capacity and volume. I hope you have enjoyed this program. Thank you for watching. Till next time, it's goodbye.